Hello, today we will learn how to solve systems of linear equations using elimination. This will be part 1 of 2 videos about elimination. So the purpose of elimination is to combine equations without previous simplification. So as you might recall, substitution, you had to simplify and then combine in case it wasn't simplified already. In this form, actually, you do not want to simplify. What you want to do is combine two equations, either by addition, subtraction, or multiplication, and get an easier equation with only one variable. So we want to combine equations without previous simplification to get a new equation with one variable. Just like before. You always want to get only one variable isolated from the rest. So addition. When you add two equations, what does it mean? Well, let's look at a very easy example. X plus y equals to 8. X minus y equals to 0. As you may recall, we already saw this example before a couple of times. So what does it mean to add? To add means that you actually add both equations. So when you add these two equations, you see that right here, the y's cancel out, and you get 2x is equal to 8. So you got a new equation, like we mentioned before, with only one variable, which is what we want. So addition is to add one of the equations to the other in order to cancel out a variable. So we find that x is equal to 4. That, as you might recall, is the solution to this system of equations. Of course, we still need to know dy, but we will not get into details with that just now. But now, what does it mean to subtract? Well, to subtract, you multiply one of the equations by -1 and then add. So let's use the same example that we did before. X plus y is equal to 8. X minus y is equal to 0. So now we want to subtract this equation. So we want to basically do this, just like subtraction that we learned way before. Well, how do we do it? Well, the easiest way to see this is to still have x plus y equals to 8. We don't do anything to the top equation. Only we are manipulating the bottom equation only. So we will multiply -1 by this equation. So by multiplying -1, we actually end up adding -x plus y is equal to 0. Now, our new equation, when we combine these two, we already saw how we add two equations right here. We just basically add, so x plus x, positive y plus -y, and then 8 plus 0. So in this case, we add x plus -x, and we get 0. Then y plus y, 2y, is equal to 8. So we find that y is equal to 4. And so here we now have this 4, which is exactly the solution we found before by graphing the equations. So we see that everything is consistent. We will always find the same solution. You only need to find which is easiest to use depending on what you are given. So you know that you have only one solution when you find you isolate successfully a variable and find its unique value. And then you can substitute for the other variable. No solution, just like before, you get a false statement. And for infinite many, you get a true statement. But now, something that you need to see, in both cases, you will often see that the variables cancel out simultaneously. Cancel out. So when you subtract, you find out that you get maybe x minus x and y minus y. So you get 0 on one side. So this is very important to see that the variables will cancel out simultaneously when you have no solution and infinite many solutions. In both cases, you will see this kind of phenomenon happen.